Hello and welcome again, students, in this class. This is lecture number 4 of carbon and its compound. So let's start this lecture without wasting our time. Okay, students, so here we will talk about allotrope of carbon. Okay, now what is allotrope of carbon? So basically, guys, carbon occurs in different forms in nature. Okay, and it has different physical properties. Let's take an example. We have diamond, and this is the structure of diamond. You can see this is what? This is diamond, and this is graphite. Now these both are made up of carbon. Okay, but although their physical properties are different, this graphite is conductor of electricity, but this diamond doesn't conduct electricity. Okay, and this graphite is present in a hexagonal array. So basically, what is a hexagonal array? So you can see here the carbon, this is a carbon atom, this is another carbon atom, this is another carbon atom. So these carbon atoms are arranged and forming this structure, and in this structure you can see this is a structure of hexagon. So the atoms in the graphite, the carbon atoms are forming the structure of this hexagonal array. I hope, guys, this point is clear to you. Now this is the structure of diamond, and here you can see that this carbon atom is connected with other 4 carbon atoms, and it is making a rigid structure, a rigid 3-dimensional structure. So because there is a difference between the arrangements of carbon atoms, so their physical properties also differs. Okay, the element carbon occur in different forms in nature with widely varying physical properties. Both diamond and graphite are formed by carbon atoms. The difference lies in the manner in which the carbon atoms are bonded to one another. So because, guys, they both are made up of carbon, but due to the difference between bondings, they are having different properties. So this is known as allotropes of carbon. In diamond, each carbon atom is bonded to 4 other carbon atoms, forming a rigid 3-dimensional structure. You can see each carbon atom is connected with other 4 carbon atoms, 1, 2, 3 and 4. So it is forming a 3-dimensional rigid structure. But in graphite, you can see each carbon is bonded to 3 other carbon atoms. Let's suppose this carbon atom is connected with 3 other carbon atoms, 1, 2 and 3. Okay, now you can see that here one valency is free. So that's why, because one electron is free, the graphite conduct electricity. Okay, so I hope, guys, this point is clear to you, and you can also see that in graphite it is giving a hexagonal array like this. Okay, so you have to remember two difference between the diamond and the graphite. First one is that here in diamond the carbon atom, or you can say each carbon atom, is connected to the other 4 carbon atoms, but in graphite each carbon atom is connected to other 3 carbon atoms. Okay, and this graphite is a conductor of electricity, but this diamond does not conduct electricity. Okay, I hope guys this point is clear to you. Now, if it is clear to you, so let's move on to the next slide and let's talk about the other things related to the allotropes of carbon. Okay, but before that, you should know that what is allotrope of carbon. The carbon atom are connected in different manner in allotrope of carbon. Okay, that's why they are having different physical properties. So I hope guys this point is clear to you. Now let's move on to the next slide and let's talk about the other important points. Okay students, so here the graphite structure is formed by the hexagonal arrays being placed in layers one above the other. So on the previous slide I told you that the graphite structure gives hexagonal arrays. Now this graphite, or you can say these hexagonal arrays, are placed one above other. Okay, you can say, or you can also see this in this diagram, that these hexagonal arrays are placed one above other. Okay, now these two different structure result in diamond and graphite having very different physical properties, even though their chemical properties are the same. So guys, this is very important point, that the chemical properties are same. Chemical properties are same, but physical properties are different in the allotropes. Okay, why they are different? Because they are having different arrangement, but they are consisting of the same carbon atom or the same carbon element. That's why their chemical properties are the same. Okay, now diamond is the hardest substance. Diamond is hardest substance, you can see. Okay, and we already know it that diamond is very hard in nature. Okay, but if I give you the example of graphite, then the nib of the pencil is made up of graphite. Okay, now that nib is very smooth and that is slippery also. So it is made up of graphite. So that's why we can say that graphite is smooth and slippery. Graphite is what? It is smooth and slippery, because you can see these layers of the hexagonal arrays are one above other. They are placed one above other, so that's why they are very slippery in nature. And I already told you that graphite is a very good conductor of electricity. Okay, this is very good conductor of electricity. And what is the reason of that? Because it has one free electron. Okay, you can see the carbon, or each carbon atom is connected to three other carbon atoms. So that's why one valency is free. It means one electron is free, and because of that it conducts electricity. Okay, but guys, we all know that non-metal does not conduct electricity, but here this graphite is conducting electricity, and we also know the reason behind it. Okay, now diamond can be synthesized by subjecting pure carbon to very high pressure and temperature. So basically guys, you can also synthesize diamond. Synthesize diamond. Okay, so you can also call it artificial diamond, where you are making it in laboratory by subjecting this, or you can say by subjecting pure carbon to very high pressure and temperature. Okay, very high pressure and temperature. If you apply this in pure carbon, then it will become diamond. Okay, and this will be known as synthetic diamond. Synthetic diamond. So they are very small, but you cannot distinguish between the natural diamond and the synthetic diamond. They are so real. Okay, So these synthetic diamonds are small but are otherwise indistinguishable from natural diamonds. Okay, so I hope guys this thing is clear to you. You might have been able to understand the difference between graphite and diamond. Okay, there is a difference between the arrangement, so that's why they are having different physical properties, but their chemical properties are same because they are consist of the carbon atom. Okay, now guys, after understanding these two allotrope of carbon, let's move on to the next slide and let's talk about the other allotrope of carbon as well. So let's see. Okay, students, so here we will talk about fullerene. This is another allotrope of carbon. Now you can see that fullerene form another class of carbon allotrope. The first one to be identified was C60, which has carbon atom arranged in the shape of a football. So this is the shape of the fullerene. Okay, here you can see 60 carbon atoms are arranged and they are forming a shape like football, like this. Okay, now guys, this is known as fullerene. So this also look like the geodesic dome designed by the US architect Buckminster Fuller. So because Buckminster Fuller designed a dome and this structure looks like that dome, so that is the reason that this molecule is named fullerene. Okay, that's why you call it fullerene, because it looks like a dome, and that is designed by the US architect Buckminster Fuller, and on the name of that architect this has been given the name of fullerene. I hope guys this point is clear to you. So in this fullerene 60 carbon atoms are arranged and they are forming a shape of football. So I hope guys these three allotrope of carbon is clear to you. The first allotrope we have discussed diamond, and the second allotrope we have discussed is graphite, and the last one is fullerene. Okay, now one thing is very important, and that is the graphite conduct electricity. So I hope guys these points are clear to you. Now after understanding these points, let's move ahead on the next slide and let's talk about the other points as well. So guys, here we will talk about the saturated and unsaturated carbon compounds. Okay, now to understand this term, let's talk about a compound C2H6. This has the formula C2H6. Okay, now this is known as ethane. This is known as ethane. We will talk about the nomenclature in the upcoming lectures. Okay, so because here H is prefix, so it means there should be two carbon atoms. Okay, now guys, if I want to draw its structure, so what will I do? The first step is to link the carbon atoms together with a single bond. Okay, and then use the hydrogen atoms to satisfy the remaining valencies of carbon. So let's take an example to understand this. You can see we have to draw the structure of C2H6. So because there is two carbon present, so I will simply connect these two carbon with a single bond. Okay, now I will complete these valencies with hydrogen. So how will I complete it? I will connect one hydrogen here, then one hydrogen here, and then one hydrogen here. So now guys, you can see the valencies of carbon is completed. Here it is connected with this carbon, it is connected with this hydrogen, here with this hydrogen, here with this hydrogen. So that means the all four valencies of carbon is completed. Now we will ensure the same thing with this carbon. You can see that here also I have connected this hydrogen with here, this hydrogen here, and this hydrogen here. Now you can see that the valencies of this carbon is also filled up. 1, 2, 3 and 4. 3 with these hydrogens and 1 with this carbon. Okay. So guys, now you can see this is the structure of ethane, which has the formula C2H6, where 2 carbon is present and 6 hydrogen element is present. 1, 2, 3, 4, 5, 6. Okay. So I hope guys this point is clear to you, that how we made the structure of ethane. Now let's move on to the next slide and let's talk about the points related to this. So guys, here it is written that you will see that the valencies of all the atoms are satisfied by single bonds between them. So if I draw that structure again, so this carbon and carbon is connected with single bond, then I connect a hydrogen here, another hydrogen here, and the same way I connected all 6 hydrogen. Now guys, you can see there is only single bond in this structure. Okay, only single bond is present in this structure. So that's why guys, this compound is known as saturated compound. Here it is written that this compound is known as saturated compound. Why? Because all the valencies are completed by single bonds only. So if all the valencies are completed by single bond, so that type of compounds are known as saturated compound. Now guys, these compounds are normally not very reactive. Saturated compounds are not very reactive. Now guys, after understanding the saturated compounds, let's move ahead and let's talk about what is unsaturated compound. So to understand this, let's take another example of C2H4. Okay, this is another hydrocarbon. And what is hydrocarbon? Where carbon and hydrogen are present only. Okay, only carbon and hydrogen should be there. Okay, so guys, this is a hydrocarbon. Now the name of this hydrocarbon is ethene. This is ethene. Okay, now we will follow the same step which I had followed in the previous example to draw the structure of this ethene. So guys, I have this carbon and I have this another carbon. You can also see this in this picture. Now guys, if we fill up these valencies by this single bond, then you will see that I will connect one hydrogen here, one hydrogen here, and then the same way I have connected one hydrogen with single bond and one hydrogen with single bond. Now guys, you can see all 4 hydrogen is connected and there is a single bond between these 2 carbon atoms as well. But the question comes here is that, is the valency of the carbon completed or not? So guys, the answer is no, because we all know that carbon is tetravalent, and here you can see 1, 2, 3, 3 valencies are completed, but still one valency is not completed. Okay, so to complete that valency, what will I have to do? I have to make double bond between these two carbon atoms. Okay, so we see that only one valency per carbon atom remains unsatisfied. All the valencies are satisfied by one valency, but one valency is unsatisfied. So to satisfy that valency, we have to make a double bond between these two carbon atoms. Okay, so now you can see that the valencies of each carbon is satisfied. So this is the structure of ethene. Ethene is what? C2H4. Okay, so I hope guys this point is clear to you. Now let's move on to the next slide and let's talk about the other points. Okay students, so this is basically the electron dot structure for ethene. You can see that the carbon and carbon atom is connected with double bond. Double bond means there is a sharing of two pair of electrons. Okay, and the other hydrogens are connected with one single bond. It means there is a sharing of one pair of electron. Now guys, you can see that the octet of this carbon has completed. Okay, 1 2 3 4 5 6 7 8. It means 8 electrons are present and octets of each carbon is completed. So this is the electron dot structure for ethene. Now there is other compound as well, which is C2H2. C2H2. Now if I want to draw the structure of C2H2, then I will again follow the same step. I will connect this carbon and carbon with single bond, and then I will connect this hydrogen with this carbon and this hydrogen with this carbon. But now guys, you can see that the valency of carbon is remain unsatisfied. Okay, 1 2, and here also on this carbon you can see 1 and 2. It means two valencies are unsatisfied. So to satisfy that valency, I will make a double bond here. So now I will check whether the valencies is satisfied or not. So 1 2 and 3. So now also you can see that the valencies are unsatisfied. So I will make triple bond between these carbon atoms. Triple bond. Okay. Now guys, if I further check, then I will get to know that now the valencies become satisfied because carbon has 4 valency. So 1 2 3 4, it means all 4 valencies are satisfied. So this is the structure of ethine. Okay, C2H2. So I hope guys this point is clear to you. Now the point is such compound of carbon having double or triple bond between the carbon atoms are known as unsaturated carbon compounds. Okay, here on the previous slide we saw that the compounds which only have single bonds are known as saturated compounds, but such compounds which have double or triple bonds, they are known as unsaturated carbon compounds, and they are more reactive. They are more reactive than saturated carbon compounds. Okay, so I hope guys this point is clear to you. We have seen here the saturated and unsaturated compounds, and we have already seen the allotropes of carbon. So I hope guys these points are clear to you. If it is clear to you, so now I am ending this lecture and we will meet in the upcoming lecture. So till then, thank you so much students, and bye bye.